1998, paper 2, question 8 on operational amplifiers. So an op amp connected in an amplifier circuit as shown below. Quite a common question for starters is state which mode the op amp is working in. That's pretty easy for you since I've only taught you one mode so far, but you need to be able to identify what that is. So if you've got a resistor, this would be R1. If you've got R1 connected to the negative terminal, remember the negative terminal is the inverting terminal, so it's an inverting op amp. This is your feedback resistor, which will always be there. So part A, part 1 is inverting mode. Now you're only ever going to be asked about two types of op amp. It's going to be the inverting or it's going to be the differential. That's what the inverting mode op amp looks like. 2. Calculate the gain of this amplifier circuit. Now that's maybe slightly confusing, but you're still using the same equation as we've been using thus far. The gain of an operational amplifier in an inverting mode is determined by the ratio of the feedback resistor to the input resistor. And if you remember back to standard grade, V out divided by V in is equivalent to the gain. So what you're really calculating there is the gain when you do V out divided by V in. So it's going to be -2 times 10 to the power 6, because that's mega ohms, divided by 100 times 10 to the 3, 100 kilo ohms, will give you -20. Now remember that gain does not have units, it's just a number. It's a number by which you multiply the input voltage by to get what the output voltage is. 3. The following graph shows how the input voltage varies with time. Now it's obviously an AC source because you can see it, it's a sinusoidal wave. Sketch a graph to show how the output voltage varies with time. So you're given the input and you've got to figure out what the output is for that period of time. Now you'll either get this totally right or you'll get it totally wrong. There's not really going to be anything in between. When you amplify a voltage like that, because it's an inverting amplifier, what it actually does is it inverts the signal. So we know that if you put a positive signal in, you get a negative signal out. So if you've got something that's fluctuating between positive and negative values, then the output that is produced must always be the opposite of what the input is. So what you actually end up with is something that looks like this. So that will be your output there. So we can draw this onto here. And then you can mark in what your values are. So this is going to be it's going to be 20 times whatever that is, so that will be 10. So you're going to have plus 10 volts here, you're going to have minus 10 volts here, and where it intercepts the y-axis is going to be at 10, 20, 30 and 40. So there are two things to take into consideration there. You've got to consider what the gain is, and also that the sign is going to be different. So when you've got a positive input, you're going to have a negative output, and vice versa. Part B, explain the shape of the output voltage graph between 2 milliseconds and 8 milliseconds. So you have this section here. So you've got a straight line. And from yesterday's experiment, it's because the op amp is saturated. That's only going to be a 1-mark question there. So all you need to say is the op amp is saturated, or you could say that it has reached its maximum voltage due to saturation. But the simplest way to say it is op amp is saturated, because we know already that the output voltage cannot be greater than whatever the supply voltage is to the operational amplifier. So here it's 15. So if it gets to a point where the gain of 20 is going to produce a voltage that is greater than plus or minus 15, then the op amp will saturate. In other words, it will level out. So that's what's happening between 2 milliseconds and 8 milliseconds. Describe 2 alterations which could be made to the circuit above to give this output voltage. So to give a saturated output voltage. There are a few things you can do. You can increase V1, because remember it is V1 that is being amplified. So the bigger that becomes, the more likely you are to produce a voltage that is greater than the supply voltage and therefore produces saturation. The other two factors are really RF and R1, so the ratio of these to each other. So you either make RF bigger or you make R1 smaller. That will give you a larger gain. So increase RF or decrease R1. So those are three things that you can say there. It only asks for two. Increase in RF or decrease in R1 will give you a bigger number for the gain, so therefore you're more likely to reach that saturation point.